Okay, so I want to make a quick recording of a problem with a bullet being fired at 60 degrees at 215 meters per second. I want to know how far does it go, how high does it go, and how long is it in the air. So let's just draw a quick sketch of what's going on. So we've got a bullet, goes in a parabolic motion. It's initially launched at a speed v0 of 215 meters per second at an angle of 60 degrees. It goes up. At the very top, we know Vy is equal to 0, and it has a height, its maximum height of y minus y0, and then it comes back down again. It hits the ground, and since the problem doesn't say any differently, we'll assume that it lands at the same height that it takes off. So we're asked to find the range in part A, x minus x0. In part B, we're asked to find the height, and in part C, we want to find how long does it take. So the first step always in doing the problem is to take our initial velocity and break it up into an x component and a y component. So v0x is equal to, if this is the angle, you can see the x component side is adjacent to the angle, so it's going to be v0 cosine theta. So that's 215 cos 60, which is 107.5 meters per second. v0y is the vertical side, and that's opposite to the angle. So v0y is v0 sine theta. If I put in my numbers, I get 186.195 meters per second. Now, I'm not going to round these numbers now. I'm going to use them as they are. All right, so I've got v0x and v0y. Now I want to solve the problem. So the first rule is that if it lands at the same height at which it took off, the easiest way to find the distance that it traveled is to use the range equation. So let me just shrink down a little bit so you can see the equation number. So that's equation number 3. So the range, which is the total distance traveled, is the initial velocity squared over g times the sine of 2 theta. Okay, and we know all these numbers. So v0 is 215 meters per second. G is 9.8 meters per second squared. And I got to square the 215. Then I want to do sine of twice the angle. So sine of 2 times 60, which is 120. All right, so if I put that, just right underneath 120, put that into my calculator, I get a distance of 4,084.86 meters. And now I want to round to the correct number of significant figures. My angle is 60 degrees, distance 215, so that's 3 significant figures for both of them. So that's, let's see, 4,080 meters. All right, so that's about 2.5 miles that it goes. That's pretty far. All right, next thing, part B, how high does it go? Right, so now I want to find y minus y0, and I'll change to red pen for a second. So I want to solve for what is its height, y minus y0, when it's at the point at the very top where vy equals 0. So I know vy equals 0. I know vy initial is 186.195. I'm going to keep all those sig figs. And I want to know y minus y0. All right, so I don't have a time. Time is in question C. So I want to look at the equations for the y direction, which are 4, 5, and 6, and find an equation which will allow me to find y minus y0 that doesn't have t in it, and that's only going to be equation 6. So I'm going to use equation 6. So equation 6 is vy squared is equal to vy initial squared. I know both of those, minus 2 times g, g is 9.8, times y minus y0. So next thing is to do the algebra. I want to get this second term with y minus y0 by itself. So I'm going to subtract that vy0 over to the other side. All right, so now to get y minus y0 by itself, I'm just going to divide through by 2g, negative 2g. So vy squared minus vy0 squared over minus 2g equals y minus y0. So at the top, speed in the y direction is 0 minus 186.195 squared over minus 2 times 9.8. I put all that in my calculator. I get, there's my number, a distance of 1,768.8 meters, and to three significant figures, that's 1,770 meters, which is just over a mile. Okay, so we've got A and B. For C, we want to know how long does it stay in the air. All right, so I want to solve for T. So if I look for what equations have T in them, I've got equation 2, equation 4, and equation 5. In fact, I can use any one of those equations. Usually, if I can, I'm going to use equation 2 because that's the simplest equation. All right, so if I use equation 2, then I have x minus x0, that's my range, I found that in part A, equals v0x times t. So t is just x minus x0 over v0x, which is x minus x0. I'm going to use my whole number, 4084.86 for the range, divide by v0x, 107.5, and I get 37.999, and to 3 sig figs, that's 38.0 seconds. Okay, what if I were to use equation 5? Equation 5, now equation 5, I want to find, looking at my picture at the top again, I want to find what is the time when it goes from one of those blue x's to the other blue x's. So for that, y final is 0 and y initial is 0. So it starts on the ground, it ends on the ground. So for equation 5, plugging in my numbers, I get 0 is equal to v0y, which I know, times t, minus 1/2 g, which is 9.8 times t squared. And this looks like I have to solve a quadratic equation. But because it's equal to 0, I can divide both sides through by t, and then I get t's canceling out, and I'm left with 0 is equal to v0y minus 1/2 gt. And then plugging my numbers in, I get, let's see, 2 times v0y over g is equal to t. So that's 2 times 186.195 divided by 9.8. And I get, this time, 37.998. And that's going to round off to 38.0 seconds again. All right, so reassuringly, I got the same number. All right, what if I were to use equation 4? Let's use equation 4 in a different way. Let's say that we're going to measure how much time does it take to go all the way up to the top. All right, so the time it takes to go all the way to the top is, we know at that height, Vy final is 0, Vy initial is 186.195. And I'm going to use equation 4. So if I use equation 4, then I've got Vy equals Vy initial minus gt. And sometimes I write Vy initial, sometimes I write V initial y. It's the same thing. Right, so t is equal to Vy minus Vy initial over negative g. And then putting in my numbers, 0 minus 186.195 over 9.8, I get, this time I get 18.999 seconds. All right, so why is this number different? Well, remember, this is only the time to go up. All right, so this is only half the time. So the total time is twice this, so it's going to be 2 times 18.999, and I get again 37.998 seconds, which I'll round to 38.0 to 3 sig figs. All right, so there's multiple ways to solve the problem. Always, if it lands at the same height it took off at, you're going to use the range equation, and if you're trying to find how high it is, you're going to use the fact that Vy is 0 at the top. And then for time, there's several different ways to do it. and usually choose the simplest one. All right, let me do one last question. This is a cannon that's fired at a target 560 meters away. All right, so we know that the range is 560 meters. The muzzle velocity of the cannon is 82 meters per second. That's V0. And we want to know what is the angle. All right, so we know the range. The range is 560 meters. We know V initial is 82.0. So the question comes, what is theta? So if I look at my range equation, R equals V0 squared over G sine 2 theta. And in this case, I know my range, I know V0, I know G, I need to find theta. So let's rearrange the equation. So I can get sine of 2 theta equals R times G over V0 squared. All right, and just plug in my numbers. The range is 4,084.86 meters. G is 9.8. V0, in this case, oops, sorry, I used my number from the last equation. The range for this one, let me do it down here. So sine of 2 theta is equal to the range from this problem, 560 meters, times G, which is 9.8, over V0 squared, which is 82 squared, and I get 0.8162. All right, so I know sine of 2 theta is 0.8162, so that means 2 theta is equal to the inverse sine of 0.8162. So twice the angle, if I put this into my calculator, twice the angle is 54.7 degrees. So theta is going to be 2 theta divided by 2, so 54.7 over 2, which is 27.4. And let's see, I've got 560 only has 2 significant figures, so I need to round that to 27 meters per second. Okay, and that last question you can see there at the bottom, I'll solve that one in class on Friday.